NASA's press conference on November 19, 2025, marked one of the most anticipated moments in recent astronomical history, as the agency finally released detailed images and scientific updates regarding Comet 3 I/Atlas, the third known interstellar visitor to pass through our solar system. The event was streamed live across multiple platforms, and within minutes it became the centerpiece of global conversation. Associate Administrator Amit Kshatriya opened the conference by firmly addressing the rumors and speculative narratives spreading online. Over the previous weeks, social media had erupted with theories suggesting that the object might be an alien spacecraft or some artificial probe created by an extraterrestrial civilization. Kshatriya, maintaining the calm and authoritative tone NASA is known for, clarified that 3 I/Atlas was definitively a comet, a natural icy body originating from another star system, and that no data whatsoever supported claims of artificial construction or alien origin. His reassurance helped redirect public curiosity toward the genuine scientific significance of this rare event. The press conference also showcased an extensive collection of images gathered by NASA's fleet of orbiters and space telescopes. Although numerous spacecraft were pointed toward the object, one in particular captured the most striking early visuals, the Mars Reconnaissance Orbiter. On October 2, 2025, when the comet was 19 million miles away from the orbiter, it managed to acquire a beautifully detailed snapshot showing the icy nucleus interacting with sunlight. This was a remarkable feat because capturing clear images of a fast-moving interstellar object requires precise timing, advanced tracking, and considerable planning for mission teams. The image offered scientists and the public a glimpse into the structure of a comet that formed around an entirely different star billions of years ago, before drifting through the void of interstellar space and eventually crossing paths with our solar system. While NASA was gathering data from deep space observatories, Earth-based astrophotographers also played an important role in documenting 3 I/Atlas's journey. Renowned comet photographers Michael Yeager, Gerald Riemann, and Enrico Prosperi were among the first to post high-quality images of the comet as it emerged from perihelion, its closest passage to the Sun, on October 29, 2025. These images circulated widely online, especially through the ICQ Comet Observations page on Facebook, where enthusiasts and experts regularly share new findings. Their photographs revealed that the comet had already begun experiencing dramatic physical changes due to solar heating. As comets approach the Sun, their icy surfaces vaporize, releasing streams of gas and dust that form tails and jets. The images shared by Yeager, Riemann, and Prosperi clearly displayed these effects, showcasing bright plumes erupting from the object in multiple directions. The development of these jets fascinated astronomers because they offered clues about the comet's internal composition and structure. Since 3 I/Atlas originated outside our solar system, it carried chemical and mineral signatures formed under unfamiliar stellar conditions. Studying how its material behaved when warmed by our Sun provided scientists with data that could deepen our understanding of how planets and comets form in other star systems. It also allowed researchers to compare interstellar comets with our own and determine whether the building blocks of planetary systems are similar throughout the galaxy or markedly different. The presence of multiple jets indicated that volatile materials were distributed unevenly across the comet's surface, possibly hinting at a complex formation history. During the press conference, NASA scientists emphasized that this was only the third interstellar object ever confirmed in our solar system. The first was Oumuamua in 2017, a mysterious, elongated object that sparked wide debate about its shape, composition, and unexpected acceleration. The second was Comet 2 I/Borisov, discovered in 2019, which more closely resembled a traditional comet. Now, 3 I/Atlas has joined this rare category, adding yet another piece to the puzzle of interstellar wanderers. The ability to observe such objects remains one of the greatest opportunities for planetary science because they provide a direct sample of material forged in distant star systems that we would otherwise never be able to access. NASA also provided updated details about 3 I/Atlas's trajectory. After swinging around the Sun at a distance of approximately 1.36 astronomical units, about 126 million miles or 203 million kilometers. On October 29, 2025, the comet began its outbound journey, gradually accelerating away from the inner solar system. While it is now moving farther from the Sun, it has not yet reached its closest approach to Earth. That milestone is expected around December 19, 2025, at a distance of roughly 1.8 astronomical units, or about 168 million miles, 270 million kilometers. Although this may sound close on a cosmic scale, it is still too far for the comet to become visible to the naked eye. NASA confirmed that even at peak brightness, 3I/Atlas will require the use of telescopes to observe. Amateur astronomers were encouraged to take advantage of the event by planning viewing sessions in the pre-dawn sky, particularly in dark, low-light pollution areas where the comet's faint glow might be easier to detect. The scientific excitement surrounding 3I/Atlas stems not only from its interstellar origin, but also from what its behavior can teach us. As comets approach stars, they undergo dramatic physical transformations. Subsurface ices evaporate, dust grains are lifted into space, and sometimes even large fragments break off from the nucleus. With this comet, researchers have already observed how its close encounter with the Sun triggered the release of multiple jets, creating complex patterns that change day by day. These evolving features give astronomers a chance to study how interstellar ices react to solar radiation, which can be compared to the behavior of typical Oort cloud comets. Every plume and tail carries chemical signatures that can be analyzed through spectroscopy. By examining the wavelengths of light reflected or emitted by the comet, scientists can determine what elements and molecules are present. This level of detail is crucial because it helps answer a fundamental question. Do other star systems form comets with the same building blocks found in our solar system, or do they contain entirely different chemical compositions? Another significant aspect of the comet's visit is its contribution to public interest in astronomy. Events involving interstellar objects have a way of capturing the imagination of people around the world, and 3I/Atlas has been no exception. From the moment it was identified as an interstellar comet, millions of people began following updates, sharing images, and discussing its origins. The idea that a small icy traveler from another star system has entered our neighborhood feels almost poetic, a reminder of how vast the universe truly is and how rare such encounters are. NASA's decision to live stream the press conference and release the newest images to the public has only heightened this sense of global engagement. Astronomers believe that interstellar objects pass through the solar system far more frequently than previously assumed, but most are small, dark, and nearly impossible to detect with current technology. The discovery of 3I/Atlas, therefore, underscores the growing capability of telescopes and detection systems. As survey instruments become more sensitive, researchers expect to identify many more such visitors in the coming decades. Each will offer a new chance to study materials formed under alien conditions, potentially revealing universal patterns or surprising differences in the way planetary systems develop. For now, 3I/Atlas continues its long journey, gradually fading as it travels outward into the darkness of interstellar space once more. Although it will never come close enough to Earth for direct exploration, the images and data collected during its passage will be analyzed for years to come. Scientists will continue examining its jets, its composition, and its behavior, piecing together the story of a comet that began its life in a distant star system, wandered across unimaginable distances, and briefly illuminated our skies before returning to the cosmic wilderness.